Alright, y'all, so today this video is going to be all over lesson 2.3. It is polynomial functions of higher degree. Before we've been talking a lot about linear functions and quadratic functions, both of which have been of degree either 1 for linear or 2 for quadratic, but now basically the functions that we're going to be talking about are going to be basically degree of 3 or higher. So here we go. Okay, so first slide we got here, we're to sketch the graph and give the end behavior. And again, and this is something that we kind of talked about on the pretest. So just take like a few seconds, to like kind of give your best guesstimate of what you think the graph would look like. Again, it doesn't even have to be like don't even have to plot points. Literally just what you know about the degree of the function and like the leading coefficients. Just go ahead and sketch out what you think it would look like. I'm gonna pause the I'm gonna give you guys time to pause the video, and we will then reconvene. All right, so now we're back. I have hopefully you've been able to draw. Gotten time to just draw your graphs in, but this is what I have drawn in. Again, if you look, let me see if I can do this here. Get this laser pointer here. So again, if you look here, this x to the third here, we've dealt with cubic functions before. We know it's going to look kind of like like this kind of crooked looking S shape. And then we know if we put the negative out in front, it's basically going to be kind of, the positive kind of goes in this direction. Then the negative basically just kind of flips it, reflects it over the x-axis there. Now, something that we haven't really dealt with, and let me see if this works. There it is. We haven't really dealt with quartic functions, x to the fourth, and honestly anything above that. But one thing that we will learn in this, one thing that we're going to learn in this lesson especially, is it doesn't matter what that number is. It only matters whether it's even or odd. And if you look at this, it looks a lot like what you would say is a quadratic, except with the exception of this little hump right here. And again, and that just kind of basically the higher degree that you go, the more like extrema that you get. But basically, your even functions are going to look, are we going to basically open either up, or if you put the negative out in front, going to open either down. So given what I just said, we have basically 4 types of criteria for graphs. You got even degree functions up here with leading coefficient, with a positive leading coefficient and a negative leading coefficient. And you got your odd degree graphs with positive leading coefficient and negative leading coefficient. Take about just a few seconds, again, going over what we have just talked about. Just take a few seconds and just sketch out what you think those graphs would somewhat look like. I will do the same here, and we'll reconvene in just a second here. Alright, so I hope you have had a chance to be able to sketch these graphs out. Again, going back to what we say up here. Yeah, let me see if I can find the laser pointer out here. Basically, as you can see here, your even degree functions are basically going to look like U's. Look like parabolas. Even if you have like a higher degree function of like 4 and 6, it still might look like a U. It might be kind of like it might like the base here might not be as an abrupt vertex. It might kind of have like it might have a bump. It might not, but generally they're gonna open up one. It's gonna either be going all up, as in if you're leading coefficients here, or your end behavior is all gonna be going to negative infinity on both sides. Then your odd degrees, again, going to, if it's a leading coefficient is positive, your end behavior while going to negative infinity is going to always be negative infinity. And then as it goes to positive infinity, as x goes to positive infinity, your function is going to go to positive infinity as well. Put that negative coefficient out there in an odd degree function, whether this is x to the third, x to the fifth, x to the seventh, so on and so forth. You get a leading coefficient that's negative. As x goes to negative infinity, it then the function will go to positive infinity, and then as x goes to negative infinity, your function will go to as x goes to positive infinity, excuse me, your function will go to negative infinity. All right, so this should be on your guided notes, a section on your guided notes for this. So talking about multiple zeros, again, this would be kind of a situation where if like you were if you were factoring a function and say you got like an x plus 1 times x plus 1 as your two factors here. Basically, if your polynomial function has a real zero c of odd multiplicity, then the graph f crosses at the x-axis at c0, and the value of f changes sign at x equals c. Basically, what that means is that the graph is going to cross at basically at that x value, at that x-intercept. If you have a 0, it's going to cross at it. The function is going to cross at that 0, and then it's either going to go from the positive y value to a negative y value, or if it's going from negative y to or it might be going to negative y to positive y. But then if it's an even multiplicity, it's not going to cross the x-axis. It's basically what's going to do. It's just going to bump off. It's going to hit the x. It's going to hit at the x-axis at, say if you got, x equals, 1 or x equals negative 2. It could be any number. It's going to hit, your graph is going to hit at negative 2. I'll kind of do a little bit of a drawing here. Say if you got negative 2 is one of your even multiplicities, it's basically going to hit and then bounce off like that. And that means that basically that's telling us is that x equals negative 2. X equals negative 2 is a 0 of f of x of whatever this function is of even multiplicity. But then up here again, going back to it, say let's go with 2, and if positive 2 is of, positive 2 is of odd multiplicity, it's basically the graph is going to kind of pass through it like that. And again, it's going to go it's going to cross the x-axis, and the value of f, basically the value of our graph right here, it's going to go, you see right here, basically over here, if you kind of look like here, on this side, it was on the negative side, and then as you went up, after you passed x equals 2 and basically onward, you go into the positive side. And again, just looking at a couple more examples here, you look at the functions here, x minus 1 cubed times x plus 3 squared. Finding your zeros here, you basically just set them equal to x equals 1, and x equals negative 3 are going to be our zeros for this function up here. But since x plus 3 is being squared twice, that means that 0 it's a multiplicity. I'm just going to write multiplicity of 2, which is even. And then 1 is a multiplicity of 3, odd. And again, it bounces at x equals negative 3, but it doesn't cross over to the positive side, and it doesn't even it touches the x-axis, but it doesn't cross the x-axis. But then for our odd multiplicity, x equals 1, it crosses at x equals 1, and then it goes from negative y values to our positive y values. Then over here again, x is going to equal negative 3, and x is going to equal 3. X equals negative 3 is of multiplicity of 5, which is odd. X equals 3 is a multiplicity of 4, which is even. And again, crosses over when the multiplicity is odd, bounces off when the multiplicity is even. Okay, so for the last couple questions here, we're going to ask you to find the zeros of these of our given functions here. Again, take time to pause the video out, and also to sketch the graph out. Take time to pause the video if you so you can work these functions out and solve for them. And I will pause the video and kind of write out the steps to do it, and then also sketch out the graph in a second here. So I'll give you all time to pause the video, and then we will reconvene. Alright, so I basically just kind of showed you my work for finding these zeros. Again, this top function up here, f of x equals x cubed minus x squared minus x minus 6x. We notice that there's an x in every single term, so we factor out the x, and then from there, that is a quadratic that we can either factor or quadratic formula, complete the square, yada yada yada. Set it all equal to 0. That's what we get here. Let me get the laser pointer out here. Basically, that's our zeros that we get. And then sketch the graph with a 0 at -2, 0, and then 3, and again, odd degree. It's gonna kind of look like, again, this like crooked S looking shape here. And this one, even more straightforward. Honestly, just set these equal to 0. The x plus 2 equal to 0, and then the x minus 1 equal to 0. X equals -2. X will equal 1. And you can kind of see it here. It's a little bit odd. There's a this is again a really rough sketch. Again, x plus 2 has an odd multiplicity. X minus 2 has a multiplicity of 3, which is an odd multiplicity. So it's going to cross at the x-axis when x equals -2. And then x minus 1, x equals 1 is an even multiplicity of 2. So it's going to bounce off the x-axis at x equals 1 here. And again, altogether, it's basically going to be a degree of, I believe, 5. Again, because it's going to basically just kind of going to look like the kind of S shape there with a little bit of a hump right here. But overall, still an odd degree function.